This lesson is going to be about the basics of good scientific graphing. To follow along with this, you're going to need this worksheet about scientific graphing. We're going to be working with the front and the back of it. You should be looking at the vocabulary at the top as we go through this, as well as some of the examples at the bottom and on the back. Whenever you're working on scientific graphs, you should be using a pencil, not a pen. Guaranteed you're going to make mistakes, and you don't want to have a sloppy scientific graph. As I said, you should have a pencil. You want to try to make these as neat as you can. You want to take your time, and you should be using some type of ruler or some type of straight edge when you're making them. So some of the basics. A graph is going to be showing the relationship between your independent variable and your dependent variable. The dependent variable is always on the y-axis, which is the one that goes up and down. And the independent variable always goes on the x-axis, which is what the horizontal axis, or the one that goes left to right. So we always have those labeled, and we always have them labeled with units. So if you take a look here, it's time heated in seconds, temperature in degrees Celsius. Whenever you're numbering, you want to make sure you have some good numbering. So good numbering is numbering that is correctly spaced and non-cluttered. You don't have to number every line, but you should include some type of tick mark that will indicate where the number is. This would be bad numbering. Although the spacing is correct, you should not number every line because it looks too cluttered. Here's some more bad numbering. The person does a poor job on their intervals and their spacing. And also, we don't use a line break in science. If I wanted to start graphing at 30, I would simply put 30 at this mark. In scientific graphing, we always add a trend line, which is going to summarize what your data is showing. Sometimes you'll hear this called as a best fit line. A trend line does not have to touch the data points. Sometimes it does, sometimes it doesn't, but they don't always have to. In this case, we're looking at what we call a linear trend line. A linear trend line is made when it looks like your data goes in some type of straight line. And you use your ruler and you follow along the best you can to all of the points in the graph. Again, you don't have to touch the points. Sometimes you will, sometimes you won't. The other type of trend line you can make is called a nonlinear trend line. Nonlinear means non-straight, and this is where your data looks like it kind of goes in a curve. You'll do this one freehand, no straight edge or ruler required. Again, if you touch the points, that's great. If you don't touch the points, that's fine as well. Another example of a nonlinear trend line. We're now looking at the back of the first page in your packet. This is the relationships and how we describe the relationships. This relationship here is called directly related. Directly related shows that as the independent variable goes up, the dependent variable also goes up. And the one thing you'll notice that all of these have in common is that they have a positive slope. So that means that the line goes up from left to right. Another type of relationship we can have is called inversely related. In this case, we have the line going down from left to right, or a negative slope. We can make predictions once we have a graph made. So we can predict data that's inside the graph line and data that's outside the graph line. So for example, if I wanted to predict this point right here, I could do that. That would be called interpolation because I'm inside of my data points. Data points start here, they end here. I predict this point, that's inside, interpolate. On the other hand, if I wanted to predict a point outside of my data, so for example up here or down here, those would be outside the data, That would be called extrapolation. Any type of prediction that is outside the data points is extrapolation. So once again, here's a nice sample graph. Good numbering on the x and the y-axis. We have a labeled x and y-axis with units, and they have a very descriptive title. Once again, expectations. Use a pencil, use a ruler or some type of straight edge to make nice straight lines. Take your time, make it nice and neat, erase any type of pencil marks. What you do now is watch the next video where we go through creating an example scientific graph together.